to the page where it says ambient pressure. It should be S7 down at the bottom. Okay, it has a data table on it. Okay, what I want you to put in your data table for trial 1 is the following: for ambient pressure, 29.17 inches. For the 30.0 centimeter magnesium standard, 0.60 grams. Your water temperature in Celsius is 20.0 degrees Celsius. The length of your magnesium is 25 millimeters, and the volume of your gas collected is 48 milliliters. That is your trial 1. That is one that I did yesterday as I ran through this. Today we are going to do a trial 2, so you're going to mix 2 trials together and get the averages for that. Now, you can read the introduction of the new lab. I would suggest you do so. It gives you a little bit of background information. You can do that later. Okay? The very first thing that it says to do is to plug in a temperature probe, which I have plugged into my LabQuest right here. It is reading 20.1 degrees Celsius. Don't put that down yet, because that is not the temperature that you're going to use. That is the temperature of room temperature right now. And it says right there, it should be somewhere between 20 and 25 degrees Celsius. So we're going to monitor the temperature of the water in the collection beaker as this reaction's happening. Number 2 says to find an internet-based weather report that gives the correct barometric pressure. We will do that at the end. So when I'm done with the lab, or actually probably while the lab is going on, we will do that. And I'll show you how to do that. Fill a 400 or a 600 milliliter beaker 2/3 full of water. So all I'm going to do, I'm going to get my paper towel, because this will be a little bit wet over here. So I'm going to take the paper towel, I'm going to fold it up just to try to keep water from going everywhere. Okay, it shouldn't be terribly bad. I'll put my paper towel down here, fill it up 2/3 full of water. That's a little bit more than 2/3, about so. So I've got my beaker at 2/3 full of water. Okay. Make the temperature as close to room as possible. That should be as close to room temperature as possible, because we've had it sitting there for 2 days. All right. Cut a length of magnesium ribbon between 2.0 and 2.5 centimeters. Determine its mass to the nearest 0.0001 grams. Now, we don't have an analytical balance in here that reads that good. So what you're going to have to do is you're going to have to take the standard, the 30 centimeter piece that I just told you to write down, and I said 30 centimeters weighs 0.6 grams, right? You're going to have to use that to figure out what our magnesium weighs by setting up proportions. Okay, that's one of the questions in the lab here. So you're going to have to do that. I can tell you right now that the length of your magnesium ribbon, is 19.5 millimeters. So you need to write that down for trial number 2. Your magnesium is 19.5 millimeters. Roll the magnesium into a loose coil and tie it with a piece of thread. It's going to be kind of hard to see. Get that in there, Kyle. It's just a little tiny piece of magnesium I coiled up. And here's the hard part, tying this into on the magnesium. It would be a little bit tougher, but I'm kind of used to tying fishing line, so I know how I would do the fishing line, so that's how I'm going to do my tied up magnesium, maybe. Get in there. Just going to make a little double knot here, hopefully. Okay, so I've got my magnesium tied on to the end of the thread. All right, now I'm going to set that down, and it says to obtain 10 milliliters of a 6 molar hydrochloric acid and put it in a 50 milliliter beaker. So, 6 molar is a kind of concentrated hydrochloric acid, okay? I don't need the fume hood. It's not going to burn my nose or anything like a more concentrated 12 molar would, but I need to put in 10 milliliters. Notice I got the cap in my hand. It never touches the table. I'm going to need, I think, about 4.5 squirts to get to 10. All right, so now I have my 10 milliliters of 6 molar hydrochloric acid. Okay, once again, the caution, it says hydrochloric acid is corrosive to the skin and eyes. Avoid breathing the vapor. Make certain you are wearing goggles. If any acid should splash on you, well, I didn't, so. Okay, but let the teacher know. Add 3 drops of green food coloring to the acid beaker and note any changes. So, I'm going to put this into my beaker, as so, and I'm going to add 3 drops of green food coloring, and you have to make note of any changes that you see. So Kyle, come in here close so we can get a nice video of this. I'm even going to put it into, well, we won't be able to see that. So let me tear off a little piece of white paper. I think you're going to be able to see it better in a white background. But here's my green food coloring, 3 drops. And when I stir it up slightly, what's your observation of my green food coloring? Okay? It's definitely not green. Okay? It's kind of a burnt orange color. A lighter yellow color. Okay? So, we got that. Make note of that somewhere on your lab, because there'll be questions about that later on. Okay? It says to carefully pour into the udiometer. So, here's my udiometer. I'm going to carefully pour my 10 milliliters into my udiometer. Now, what you're going to see, ladies and gentlemen, what you're going to see is that this is pretty good deal of having this color in here, and I'll show you why here in a bit. Okay, so I just added this. It says while holding the udiometer slightly tipped, very slowly pour distilled water from your 100 ml beaker, being careful to layer the water in the acid. So I'm just going to get my 100 ml beaker. I know I should have plenty of this water because this is only 50 mLs, but I'm going to fill it completely, and I'm going to do it slowly so that I layer and keep that acid at the bottom. So Kyle, are you getting a pretty good shot of that?
Yeah.
The coloring that it's looking? And folks, are you noticing the coloring?
Yeah.
I'm going to fill it almost all the way to the top, which I have here. Okay, and notice how it looks. Okay, now I'm going to set that here for a second. Just put it into my burette clamp is what this is called. Okay, after I've done that, it says lower the magnesium core into the water to a depth of about 5 centimeters. Use a one-hole stopper to hold the string in position in figure 1. The stopper should displace some water from the liquid. So I'm going to come over here. I have a one-hole stopper right here that I'm going to put in, but I need to get my magnesium strip, and I need to put it about 5 milliliters. I'm going to need a cut on the string. So grab those scissors. Put that string up right on my victim. Okay. I'm going to take this and I'm going to put it in here. The toughest part of this is getting it to sink because it doesn't want to sink. The magnesium doesn't. There, I've got it to sink. Okay, I need to get it about 5 centimeters. Now, a little bit of water is going to come out here, but that's not going to hurt anything. Okay, and how do I know that that's a little bit of water coming out of here and that that's not acid? Because if it were acid, what color would it be? The orangish yellow there down at the bottom. Okay, but nonetheless, just to practice a little bit of safety, I'm going to need
It's still filming, right? Upside down.
a pair of gloves. I don't think if I wouldn't have the gloves that it would be anything to me. Okay? Because what you're going to see is this is going to end up being pretty diluted. Okay? Now, I've got the coil. I'm going to cover the one hole with my finger and invert this and put it into this beaker of tap water there. So I put my glove on. I don't really need to, but I'm going to have to. Okay, what I'm going to do is I'm going to simply take this, take her out of here, invert it, put it down into the water, as so. Clamp my tube in there. It's not going very good. I need to move this over. Get my hand out of the way. And what you should see is what's happening with the acid. Okay? What's happening with the acid? Where's it going? It's traveling down. Why do you think so? It has a higher density than what the water does. Okay? So we can see the acid moving down. Note our temperature, 17.9 degrees Celsius right now. Okay. I can see that the green, I'm going to lift this up just a tad bit to make sure that that is not sitting on the bottom. But I can see that the green's getting down to where the magnesium is. What should be happening here in a fairly short amount of time is that magnesium is going to start bubbling. I can see a couple little bubbles there. Okay. So the magnesium will start bubbling, and we are going to sit here and just wait until the reaction is finished. Now, how am I going to know that the reaction is finished? No more bubbling. Okay? No more bubbling. So, why don't, Sean, right behind you on that computer, turn that computer on and get on the weather channel. While we are waiting for the reaction to take place, Sean's going to call up the weather channel and we're going to get our pressure measurement. Now, something about the pressure, okay? Something about the pressure, I didn't even know this, okay? But we are going to need to convert the pressure into our elevation. All right? Because what the weather channel does is to be able to compare the pressure from different places, they just convert it to what it would be at sea level. Okay? Now, obviously, if I go to Denver, Colorado, it's a little higher elevation than where we are, correct? Okay? So that pressure is going to be a little bit different, but they convert it back to sea level so it's comparable to us, so we can do the comparisons. So we're going to have to take our reading and convert it to our elevation. And just off the top of my head, I think it's something like 892 feet above sea level that we are here in Seatown. Okay? So, if you look now, we're going pretty good. Notice the beaker on the bottom. Okay, this is why I love the food coloring. Can you see the water being displaced? Obviously, yeah, because the green's coming out of the bottom of the stopper. So that water's being displaced. Here I have my magnesium strip. Okay, on the lab it says to use in between 2 and 2.5. When I used 2.5 yesterday, it went to 48 milliliters. I was sitting there wondering, boy, am I going to take it out of the bottom there? Because I didn't want to do that. So I was getting worried. If I would have used 2.7 millimeters of magnesium strip, it could very well have filled up that entire tube, which is what our problem was yesterday, right? Okay? So, I'm not worried about this one because I used even less today than what I used yesterday. So we should be fine once the reaction takes place. But as you can see, it's bubbling pretty good, isn't it? What do you see about the temperature? It's going up a little bit, right? You might want to make a note of that the temperature is increasing a little bit in my water bath around. Okay? Temperature is increasing slightly. Did you get a picture at temp?
Yeah.
Up there, Kyle, for me. Now, let's go back over here to where Sean is. Sean, would you put in there, is this on Seatown? Okay. All right, now, do not put this into the barometric pressure one, the ambient pressure. Okay, do not put this there, but make a note that right now the weather channel is reading 30.08 inches of mercury. 30.08 inches of mercury. Now, what do you think, Kyle? What do you think about our reaction?
I think it's about stopped. It looks like it's not really bubbling that much anymore.
Looks like our reaction is about stopped. It's not really bubbling that much anymore. Okay? So, what we are going to do, all right, is I am going to take this and I'm going to take it out of here. I have my finger so that I have no gas escaping out of there. Now, what I am going to do is I have to put this into here because I need to get this level of the water at the same level that I have in the tube. Why? Because I need the pressures to be identical. All right? Come up here. Somebody come up here closer. Not Kyle, somebody else. Okay? I want you to look. What am I reading about right here?
42.
Okay?
Oh, wait, no. 41 point.
It's going the other way. It's going down, so that's 40.8.
Yeah.
Okay? I'm reading right now at about 40.8. Now come back here. Come back here. Don't go so far. Watch what happens when I go down and I increase the pressure. Okay? What am I reading now?
Less than that.
Less than that. Okay? So by increasing the pressure, I have decreased the volume. So what I'm going to do is I'm going to get back to my pressure, and I'm going to say right now with the pressure at where it should be, we're going to go on the top, on the bottom. We're going to say 40. Okay? 40 milliliters. All right? So, 40 milliliters is my volume of the gas being collected. Okay? I'm going to go ahead and have Kyle shut off the video, and I'm going to show you how to convert our pressure.